So on 205, we're talking about using bar diagrams, and we have to know the whole thing and the parts. For number 1, how many total does this bar represent? All 50 states. And so I'm going to write 50, means the whole thing. We know from the last example that there were 15 states that had the bus law. Number 1 says, suppose 9 more states adopt similar laws. How would we draw that on our picture? What would we do? Kyra. Yes. And then how many is in this? Do we know? We could mental math it, but right now we don't know, right? And so I'm going to give that a letter. You can give it whatever letter you want, provided you define the variable. That means tell me what the letter means. How would I write this equation out based on what you see? What's that equation going to be, Jesselyn? Plus what? Plus x equals 50. That is spot on. She said, I'm going to take that part plus that part plus that part, and it has to be this total. You are absolutely correct. Now, to be honest, I would prefer to simplify that. Could we make an equivalent equation that has the same value as that? How could we make this easier to look at? Elliot. 24 plus x equals 50. That's calling combining like terms. That means if I have a number and another number, I can combine those things. I don't know how much is in there, so I can't combine that yet, but I can write this. These are equivalent equations. Just like when we wrote equivalent expressions, they had the same value. These do as well. I'm with you, Mrs. Smith. Yeah? How about number 2 then? Number 2 says, how would the diagram change if the U.S. Virgin Islands, and that counts as one thing, and Puerto Rico are counted with the United States? I want you and the person you're sitting next to, you look at those and you talk to me. How does this picture change if the U.S. Virgin Islands and Puerto Rico are counted with the United States? Discuss. Go. You can. We are going to write it down. Yep. Huh? We don't know. So how does that change our diagram? Because we don't know the answer to that question. What do you think? Huh? Where? To my picture. Yes. So instead of 50 states, there'll be... Yes. You got it, because it's going to change our total. Thumbs up if you and your partner have come up with what you think is the right answer. Colton and Marie haven't discussed yet. Go. You aren't required to like it. You guys have an answer or no? Okay, so keep going. If you think you have an answer, draw what you think is the picture, and then I'll call on you. So, yeah, because it says how would the diagram change, so go ahead and do that. Colton and Marie, interact with each other. What do you think is going to change on this picture if you have the U.S. Virgin Islands, which is all one thing, and Puerto Rico counted with the United States? Give me your best guess. I'm still looking for you to at least glance towards each other and interact. You're not required to like each other. Nor are we going to stay in these seats much longer. You are required to interact when I ask you to. I know. It's going to be great. I know. It's wonderful. It's a glorious thing. Because guess what? In life, you don't always get to work with the people you like the most. It's a skill. You're welcome. And then when you get to pick, you know who to work with. You don't always get to pick. You need both. You need to know who you work well with, and you need to know how to work well with people you don't really like. I do. And sometimes we don't agree, even if I like them, and we have to learn to work that out too.
What did Dad say?
Agree to disagree sometimes works, or sometimes you have to figure out a way to compromise.
Or just do what my planner says.
Or do what your planner says. Marie, oh, you guys got it? All right, and so I have a new box. I want to know how the diagram changes. Bree.
Instead of 50 total states, it'd be 52 total.
Good. How many groups, thumbs up or thumbs down, got that right? Yay. Because the total changed. And then our picture would still remain the same. We still know there are 15 that do. It didn't say Puerto Rico or the Virgin Islands did or didn't. And so unless they give us information that says they would, probably that part would stay the same. But the total changes. And so when we're doing bar diagrams, it is critically important, what's the part or parts, what's the total? I think I'm with you, Mrs. Smith. And so we have example 2 on the top of 205. Jack has baseball cards. He sold 7 of them. He had 29 left. Write and solve a subtraction equation to find the number he had at the beginning. Oh, but I know what the answer is, but I don't know how to make a subtraction sentence, some people say. And so when I look, he sold 7 of them. That's a part of his collection, right? He had 29. Well, that's still part of his collection, right? So now this part, I know both parts, don't I? What don't I know? I don't know the total. Wait a minute. They want a subtraction equation, but if I add those together, is that a subtraction? I know how many total, but that does not tell me what a subtraction sentence is. So you have to take the whole thing and take away one of the parts. And so here they decided that they were going to take the total and take away 7, knowing there were 29 left over. Because the directions say you have to do a subtraction equation. We could make an addition equation, right? We could say 7 plus 29 equals n, but that would not be following the directions. We need to be able to make equations that match what we're being told to do. Yes, Jesselyn. Yes, we are doing the total, and they picked minus 7 equals 29. I would know the total because if I had, what's the opposite of take away 7? Add 7. If I add 7 on this side, the additive identity property says n would be by itself, but I have to do what on this side? Add it. You have to do the same thing. I would get 36. Couldn't I do this? Couldn't I do the total take away 29 equals 7? Based on this picture, could I do that? I could. And they didn't say which one you had to do, so this one is an equivalent one. Could I do 29 take away 7? Would that be equivalent? I'd get 22, and so order matters for subtraction. You have to start with the total, and you're going to take away one of the parts to get the other part. And so sometimes, based on what they ask us to do, we have to think about the problem in a different way. This bar diagram actually could do any of 3 different equations. Okay, I could do an addition one, and addition's commutative, so they'd be equivalent. Technically 4. I could do 2 different addition ones or 2 different subtraction equations based on this picture. We're going to get better at being able to figure that out, but if you don't know the part and the whole, you get it wrong. That example makes sense, or I'm still confused, Mrs. Smith?